Hello everyone. In this video we will learn about linear inequations. Linear inequations is a topic of class 10th. So let us start by understanding the meaning of linear inequations. So we all are familiar with this type of expressions like 2x plus y is equals to 6. This expression, it is known as linear equation. So why it is equation? Because of this sign of equality. If the sign of equality is there, that means the given expression is equation. Now here we will deal with inequations. So in inequations, the sign of equality will not be there, but rather than this, the sign of inequalities like greater than, less than, greater than, equal to, less than, equal to. So these are the four signs of inequalities. So instead of this sign, these four signs you will see in this chapter. So something like this: 2x plus y is greater than equal to 0, 2x plus y less than equals to 0, 2x greater than equal to y, so x less than y less than equal to, we can say. So you will see inequations, the expressions like this in chapter. So inequations look like this. Now what is the meaning of linear inequation? See, the name of the chapter is linear inequations in one variable. This is linear equation. Why it is linear equation? Because the degree of the variables. See, in this given expression, x and y, two variables are there. So variable, I want to explain that variables are the any English alphabets like A, B, C, D, X, Y, Z, anything. These are the variables. And why this is linear equation? Because of the degree. Degree of the variable should be 1. So if I take this one, 2x square plus y square is equals to 0. So this is not an example of linear equation. So degree should be 1, only then the given expression will be linear. And in one variable. This example I took, this example is in two variables. See, two terms, two alphabets are there, x and y. That means this is example of linear equation in two variables. So here we will only deal with linear inequations in one variable. That means the expressions like this: 2x plus 6 greater than equals to 0, 2x less than equals to 4, x minus 4 greater than 0, x plus 4 less than 0. Only this type of expressions we will deal in this chapter. The variable will be 1. The degree of the variable, it should also be 1 because it's a linear inequation, and the sign of inequality will be there. So this is how linear inequation looks. So I'll repeat. So linear inequation is that expression, we can say, in which the sign of inequality is there, and moreover we will deal linear inequation in one variable. So only one variable will be there, only one, x, y, z. So any variable can be there. So it can be y also, it can be a also, but only one in one inequation. So why do we use inequations? You can see here, see the sign greater than, less than, greater than equal to, less than equal to. So these expressions, they are telling us that the reason we use inequality is to compare the two things. For example, x, it is greater than y. So two things I am comparing because it's not exactly equal. It may be more than, it may be less than, maybe more than, equal to, or less than equal to. So we are comparing two quantities using the signs of inequalities. Now in order to see, our expressions will be in this form: 2x is greater than 4. Now when we solve linear equations, like in earlier classes, we were finding the values of variables. So same thing here also we will do. We will solve the inequation to find the value of variable, any given variable. If I want to solve this, I will find the value of x. So solving linear inequations means finding the value of the variable given in that linear inequations. So for finding that value, we will follow certain rules. So let's discuss those rules now. So let us start with the rules now. If I have any inequation, that is 2x minus y, it is greater than 4, not y, we will use only one variable. So 2x minus 3 I can write. So I have taken an example. So while solving, what we can do, in order to find the value of the variable, this minus 3 is a negative integer. See, when we shift negative integer in an inequation to other side, this negative integer will be changed to positive integer. So minus 3, it will be changed to plus 3 plus 4 as it is, and the sign of inequality, it will remain same here. Then second rule is that if I have this thing, so again I have taken one example, 2x plus 3 is greater than 6. Here if I want to find the value of this variable, given variable x, then I can shift this positive integer to other side. See, when in linear inequations, when we shift positive integer to other side, the sign of the inequality remains same and positive integers will be changed to negative integer. So these two rules are exactly same like in linear equations we do. When we shift negative term to other side, it changes to positive, and when we shift positive term to other side, it changes to negative. Same rules. Third, see, if I have, I'll take same example. Now if I multiply or divide the given expression, by same number, so that is, if I multiply the given expression, see, the change should be on both the side, 4 into 2. In that case also, the sign of the inequality, it will remain same and there will not be any change in the inequality. If I want to multiply both the sides of the linear equation then with same number, then I can do that also while solving the linear inequation. There will not be any change in the sign. So same goes with division also. If I divide it by same number, it won't make any difference. See, here I will explain also. See, if this 2, if you shift to in multiplication, if this 2 you shift it to other side, it will change to division. 2 and 2 will get cancelled. So overall the inequation will remain same. So that is why when we multiply or divide the linear inequation with the same number, this also if I shift it to other side, it will change into multiply, because this division, on changing the side, it will be changed to multiplication, like we know in linear equations also we do same thing. So these two will get cancelled. So overall there is no change in the given linear inequations. So this rule says that if we multiply or divide the linear inequation by a same number, both sides, provided both sides we are doing, then there will not be any change in the linear inequation. The sign of the inequality will also remain same. Fourth rule is that if we multiply or divide, see, same example, 2x minus 3 is greater than 4. If I multiply or divide the given linear inequation by same negative number, so like minus 2 or minus 1, any negative number, minus 2x into 2x minus 3 greater than minus 2 into 4. So if I multiply or divide also, I will do 2x minus 3, 4. So I am dividing by minus 2. Here both the sides I have multiplied by a negative number, here both the sides I have divided by a negative number. So in that case, this sign of the inequality, it will change. If it is greater than, it will be changed to less than in both the cases. Then fifth rule, if I do, see I have the in equation 2x minus 3 greater than 4. If I do the reciprocal of both the sides, if I do the reciprocal of both the sides of given linear inequation, so like this, reciprocal means interchanging of numerator and denominator. So here see, nothing is written, that means 1 is there. So 2x minus 3 by 1, if I do its reciprocal, it will be changed to 1 by 2x minus 3. 4 by 1, if I do its reciprocal, it will be changed to 1 by 4. If I do reciprocal of both the sides, then also the sign of the inequation, it will get changed. If it is greater than, then it will be changed to less than. So these are the rules. I will recap all the rules once again, and you will understand all the rules in a better way when we do the questions. See, first rule is that, first two rules, it is very much similar to the rules when we solve linear equations. See, negative number, if we shift to other side, it will be changed to positive number. Positive number, if we shift it to other side, it will be changed to negative number, provided the sign of the inequality, it will remain same. Third rule says, if we multiply or divide both the sides of the linear equation with the same positive number, there won't be any change in the sign of the inequation. If it is greater than, it will remain greater than. If it is less than, it will remain same, no change. According to fourth rule, if we are multiplying or dividing both the sides of the linear equation by a same negative number, see here we did by positive number, but the same thing, multiplication and division both the sides of the linear inequation by a negative number, then this sign of the inequation, it will change. If it is greater than, then it will be changed to less than. Fourth rule, if we do reciprocal of both the sides of the linear inequation, then also the sign of the inequation will get changed. So all these rules we will use to solve the questions of the exercise. Let's start with the first question of the exercise. In the first question of the exercise, we have to state whether the given statement is true or false. See, two statements are given to us. The first one says x is less than minus y, which implies that minus x is greater than y. So this we can just assume any numbers and then we can check. See, these are the true statements. If this is there, then this is also true. That is what they have asked here. Then x is less than minus y. We have to assume any number such that x will be less than minus y. So any number I can assume x equals to minus 2 and y also I'll assume as equals to minus 1, because I don't know, I just have to assume in such a way that x should be less than minus y, because this is the given condition. We have to find it out if this thing is there, is it true or false. So I have just assumed any two numbers which should satisfy this inequation. So x is minus 2 less than minus y, y is minus 1. So minus 2 is less than, see, minus and minus, it is plus, so 1. Minus 2 is less than 1. So this is the given thing, and it is true also. You know, all the negative numbers, they are less than positive numbers. Then they are saying minus x is greater than y. X is 2, so that means minus of minus 2. X, the value of the x which I have assumed is minus 2. 1 minus is already there. Now I am just substituting here. Is greater than, what's the value of y? Minus 1. So minus and minus plus, so 2 is greater than minus 1. This is also true. So that means this first expression is true. See, any numbers, any different numbers also you can assume and you can check. The thing is that the numbers which you are choosing is according to this inequation. Like I have chosen minus 2 and minus 1, which is already true for this inequation. Then the same values you have to substitute here and check whether this is true or not. I have substituted here, and I know minus 2 is less than 1 and 2 is greater than minus 1, because all positive numbers, they are greater than negative numbers. So, though both the conditions are true, therefore, the given thing is true. Second, it is minus 5x is greater than equals to 15. So, we have to solve this minus 5x. This how can we solve? We can just divide, because in the rules I have explained to you, we can divide both the sides with the same positive number and the inequations will remain same. So, 5 with 5 I am dividing both the sides. So, 5 and 5 will get cancelled, 5 into 1 and 5 into 3. So, I am getting minus x is greater than equals to 3. Minus x is greater than equals to 3, but here only the value of x they have mentioned. So, what I can do, I can multiply both the sides with minus 1. So, minus 1 into minus x and 3 into minus 1. So, in the rules we have learnt that when we are multiplying both the sides with a negative number, the sign of the inequality will change. If it is greater than equal to, it will be changed to less than equals to. So, minus minus is plus, this and this minus will get cancelled. So, x is less than equals to 3 into minus 1 minus 3. So, if minus 5x is greater than equals to 15, then after solving this inequation we are getting then x is less than equal to minus 3. But what they have given, that if this thing is there, then x is greater than equal to minus 3. But if this thing is there, after solving we got x is less than equals to minus 3. So, this is false. If they give us this thing, then it will be true. 2x is less than equal to minus 7. So, what they have done, 2x they have divided it by minus 4, both the sides. 2x also they have divided by minus 4 and minus 7 also they have divided by minus 4. So, they are saying if 2x is less than equals to minus 7, then 2x by minus 4 is greater than equals to minus 7 by minus 4. So, this is true. Why it is true? Because we have learnt in the rules, when we are multiplying or dividing both the sides of the inequation by a negative number. See here, both the sides we are dividing by a negative number, then this sign of the inequality, it will change. In the first expression it is less than equal to, and after dividing by a negative number it changed to greater than equals to. So, which is true, we have learnt after multiplying or dividing by a negative number, the sign of the inequation changes. So, this is true. In the fourth one it is given 7 is greater. If 7 is greater than 5, then 1 by 7 is less than equals to is less than 1 by 5. So, what they have done? They have done reciprocal of both the sides. See, it is 7 by 1, it is 5 by 1. So, what they have done? 1 by 7, 1 by 5, and sign of inequality. It was greater than, here it changed to less than. So, that is what we have learnt. If we do the reciprocal of both the sides, then again the sign of the inequality, it will change. So, they have changed the sign, which means this is true. See, only in two conditions the sign of the inequality change. First condition is that when we are multiplying or dividing the given linear inequation by a negative number, like here we have divided, in that case the sign of the inequality, it will change. Or when we are doing the reciprocal of both the sides of the inequation, then also the sign of the inequality will change. Let us do the second question now. Second question is also true or false. If this thing is there, then this is also true. That is what they have asked in each and every part. So, they have mentioned if A is less than B, then A minus C is also less than B minus C. See, this type of inequation you can just, like in the previous question first part we did, we can assume some number according to first, and we can check whether those numbers are true for this also or not. So, A is less than B, I can assume any number. So, A I will assume as 2 and B I will assume as 3. Now, we know 2 is less than 3. let's check for this. C is common number which they have subtracted from both the sides, so C I'll assume as 1. So A is 2, let's substitute the values in this inequation and check whether it is true or not. So 2, A is 2 minus 1 less than B I have assumed 3, C is 1 as I have assumed it. So 2 minus 1 is less than 3 minus 1 2. This is also true. 1 is less than 2. So if 2 is less than 3, then 2 minus 1 is less than 3 minus 1. Sign of the inequality, it will remain same. They have also given the same. So this is true. You can assume any other number according to this inequation and you can check for this. So it is true, and from here you can also learn one thing, that if you are subtracting a common number from both the sides of the inequation, then also the inequation or the inequality sign will remain same. See, same number we are subtracting from both the sides. Sign of inequality same. Second one, if A is greater than B. If A is greater than B and then one common number, if we add on both the sides, there will be same inequality sign. So let's check. A again I will assume, so since it's a greater, so let us assume A as 3 now and B as 2, because A is greater than B. So 3 is greater than 2, so accordingly you can assume any numbers. Now any common number, so C I am assuming C equals to 1. So A is 3, 3 plus 1 is greater than 2 plus 1, 3 plus 1 is 4, 4 is greater than 3. It is also true. So from here also you can learn, if in an inequation we are adding one common number on both the sides. Common means same number, not common. So same number, when we add on both the sides, the sign of the inequality, it will remain same. You can see, which means this is also true. In third part, it is if A is less than B. If A is less than B, so accordingly we have to choose. 2 is less than 3, so the value of A I have assumed as 2 and B I has assumed as 3. See, these things are already true. If this thing is there, then we have to check whether this is also true or not. Here with same number, we have multiplied both the sides. Same number, so same number C we can assume as 2 or 5, any same number, any number, because it's a positive number, so any positive number we can assume. So they have multiplied both the sides of the inequation with same number. So 2 into 5 is 10 and B is 3, 3 into 5 is 15. So what they have given, if A is less than B, then AC, it will be greater than BC. This thing, is 10 greater than 15? No, it should be same sign. It should be the sign of less than, then 10 is less than 15, but they have changed the sign. So this is false. See, from here we can see, if with same number we are multiplying also, and we have done this thing in rules also, if we are multiplying or dividing both the sides of the inequation by a same number, then the sign of the inequation, it will remain same. So it should be this, less than. It shouldn't be changed, but they have changed, due to which this is false. If A is greater than B, then A by C is less than B by C. So what they are doing here, both the sides of the inequation, they have divided by the same number. So we have learnt during the rules, if we multiply or divide both the sides of the inequation with the same number, then the sign of the inequation, it will remain same, but they have changed the sign. That means it is false. So this you can take any example and see also. Say if x I take 2, or not x, A I assume, because A is greater than B, so A I will assume as 4 and B as 6. We know 4 is B as 2, we know 4 is greater than 2. So according to this inequation we have to assume the numbers. So A is greater than B, so I assumed A as 4 and B as 2. C we can assume as 2 only, we can assume any number. So 4 by 2 and 2 by 2, it will be changed to 4 into 2, 2 into 1, 2 into 1. So 2 and 1. So they have written 2 is less than 1, but it is greater than 1. So due to which it is false. See, same number also you can assume. I have just assumed C as 2. So any numbers of your choice you can assume according to this inequation, and directly also you can do, because we have already learnt in the rules that if we are dividing both the sides of the inequation with the same number, same positive number, then the sign of inequality will remain same, but they have changed the sign of inequalities, due to which it is false. If A minus C is greater than B minus D, then A plus D is greater than B plus C. So first rule and second rule here they have applied. First rule we can say just rearrangement of terms they have done. This negative number they have shifted to other side. So negative number, see A and B they have kept on same side. So minus C they have shifted to other side, it changed to plus C. Minus D they have shifted to this side, it changed to plus D. So A plus D is greater than B plus C. There also we learned sign of the inequation, it will remain same. So same sign they have mentioned. So A plus D is greater than B plus C. Here also they have given this thing, so this is true. Last one, if A is less than B, then A minus C it will be greater than B minus C. From the rules or the first one we have done, we have learnt there, if we are subtracting same number from both the sides of the inequation, then the sign of the inequality should remain same. So here should also be less than. We can take example also. So 2 is less than 3, we can take. C is a positive number, so C we can assume as 1. So 2 minus 1 and 3 minus 1. 2 minus 1, 1, 3 minus 2. So it should be same sign, because 1 is less than 2, but they have written greater than sign. So 1 is greater than 2, no, it is false. Now so we have completed first and second questions of exercise 4A. I'll continue with the next questions in the next video. Thank you.